Alrighty, so we have a graph, f of x, capital F, right? Not lowercase f, capital F. Capital F equals the integral. Integral always means area under the curve. So capital F is area, okay? So that's what it means. Area of what? That graph over there, okay? It says there's lines and semicircle, okay? And our goal is to sketch capital F of x. We'll do that. They don't even ask you to do on that one. Okay, so let's start solving. Capital F of 2. So we plug in 2 everywhere there's an x. Okay, so 2. Where else is there? Where else do I plug in 2? The top, right? There's an x up there at the top. So from 0 to 2, f of t. So f of 2 means the area under the curve from 0 to 2. Okay. From 0 to 2, area is here. Okay, that's the area under the curve. It's positive. And it's half of the semicircle. So in other words, a quarter circle, right? It's half of the semicircle. Okay? So it says there's a semicircle, so there's a half circle. So you can find, so the easiest way I think is just to find area of a quarter circle. So area of a circle, yes, the area of a circle is pi times r squared, right? Quarter circle, you just divide by 4. You just divide by 4. So yeah, so it's going to be pi times 2 squared, that's the radius, right? Divided by 4, which is just pi, right? Because 2 times 2 is 4, divided by 4 is 1, so it would just be pi. So that area is pi. Okay. Letter B, f of 6. I'm going to plug in an 6 everywhere there's an x. So again, this one's asking capital F of 6. It's asking for the area under the curve from 0 to 6. Okay, well, I already know the area from 0 to 2. It's pi. The other area, what's the size of this going to be, the other side? Pi. Also pi, right? Because we're just cutting the half circle in half. So this is also going to be pi. I don't have to calculate it. It's going to be the same. And then all I have to do is find the area here. This is going to be negative. Looks like just a triangle. Okay, so area of a triangle, base times height divided by 2. So it looks like 2 by 2, it's a 2 by 2. So 2 times 2 divided by 2, we're going to get negative 2 because it's underneath the curve. So you have pi plus pi minus 2. Well, pi plus pi, you can add those together. If you have pi plus pi, that's just 2 pi. So 2 pi minus 2. Those aren't like terms, so I'm done there. Okay, so I want you to do C and D. Do C and D. Careful with those. You can do it, but just careful with them. Okay, so that's how you set it up. Why did I say be careful? Why do you think I said careful?
Because the bounds should be flipped.
Yeah, for each of them, the bounds should be flipped. The bottom is not the lowest. The bottom is actually the biggest. So this is what it should look like. for both of them, the bounds should be lower. The bottom bound should be the lower bound, and the top bound should be the higher bound. Okay, now we can go up there and find area. So from -2 to 0. Yeah, so it's going to be, so you can do it a couple ways. This part here, it is a trapezoid, so you can use the trapezoid formula. Or you can divide it into a rectangle and a triangle. Either one's okay. You'll get the same answer. So if triangle, or if you divide it up, it's 1 by 2, so this is going to be +2. And then 1 by 2 divided by 2, you'll get 1. So either way, you'll get 3 as an answer.
-3?
Yeah, -3, thank you. Thank you. I made the mistake of not remembering this guy. You got to remember this guy. Okay. Alrighty. Okay, so the next one is -4 to 0. So it's the rest of it. It's the rest of, so we got this part here, and then I have this part here. Okay. So this little sliver is a half by 2. So that's just going to come out to 1/2, or 0.5. This one has a base of 1.5. So it has a base of 1.5. I'm just going to change it to 0.5. And it has a height of 2. And I got to divide it by 2.
So it's just 1.5?
Yeah, so the 2's will cancel out, so it's just 1.5. So one's negative and one's positive, though. One's negative and one's positive. So when I add up this guy and this guy, I get -1. But I got to multiply times the negative in the front, right? So it's actually going to be +1.
What happened to that 2 and 1? So it's 3 right there.
Oh, sorry, I didn't count that, yeah.
That would be -2.
Yeah, I forgot to count those. So I got to count all of this. So yeah, I was just going from that spot to that spot. Let's see. So I got to count this, and I got to count this. So it's 3.5 minus 1.5, 2, and then it would be -2, right? Thank you, yeah. I was overlooking that part. Okay. Okay, so that's capital F. We know capital F is area. So now the next one says capital F prime, so the derivative. Well, one level underneath area is the actual graph. Okay, one level underneath the area is the actual graph, the y values, right? So what they're asking for is, what is the y value? What is the y value when x equals 4? What is the y value when x equals 4?
0.
0, right? Yeah. Right there. So f prime of 4 equals 0. Same thing over here. What is the y value
2.
when x is 2? Yep, it's at the top of the circle, half circle. Top of the half circle right there. So it'd be 2. Y is 2, x is 2. Oops. Yep. Those are the easiest to find. You just got to know where to look. F double prime. F double prime is the same thing as F prime. When we're talking about F double prime or F prime, we're talking about slopes now. So what is the slope when x equals 5? So let's say, yeah, -5. When x is -5, that's that dot right there. Now that dot is a part of a line segment. This guy right here, right? What is the slope of that? -1, right? Negative down 1 over 1. -1. So f double prime of 5 is -1. F double prime of -1.5.
0.
That one would be 0, yeah, because -1.5 is there, so that means the dot would be there. This is part of this guy here. Anything horizontal is going to have a slope of 0. 0. Okay, again, these are slopes. Okay. All right, so now we come back to the increasing, decreasing, maximum, minimum, all that good stuff. We come back to it. Okay? So on what subinterval from -4 to 6 is capital F increasing or decreasing? So I know that the justification, I know this part, is going to be when f prime is positive or when f prime is negative. I know that. When the derivative is positive or the derivative is negative. So I'm not going to, so I won't get to that yet. So my question is, how do I look at the graph and figure that out? Where do I look on the graph?
For the y value, negative or positive.
So I need to know the derivative of this guy, right? The derivative of this guy is going to be this guy. That's the y values. So when are the y values positive or negative? That's what I'm looking for. When are the y values positive or negative? Okay, so let me erase all this. So the y values are positive there, and they're negative
From -4 to
One
-2.5.
Okay. So yep, that's where we're going to have, that's where positive and negative is going to be. Okay, so let's write this down. Let's go increasing first. Increasing, so
2.5 to 4.
so let's see. Increasing.
It wouldn't be to just 0 because
So 0 isn't a critical value because it doesn't change signs, right? It stays positive. Yeah, so if it went down, definitely. But because it doesn't change signs, we'll just continue. Yeah, we'll just continue, yeah. So from -2.5 to 4. -2.5 to 4. Yeah, why? That's a great question. Why don't, 0, it touches, right? Why don't we have that? Because it doesn't change signs. It continues what it was before, okay? So yeah, so it would be -2.5 to +4. -2.5 to +4, and then our justification, because now we're not going to use this. We're not going to use little f prime, because we're going to use uppercase F. Uppercase F. Now, if you want to use little f no prime, you can do that. You can say little f of x, because it's the same thing. Or even better, say capital F prime, because capital F prime of x is greater than 0. Okay? Next is decreasing. Decreasing everywhere else. So decreasing would be from -4 to -2.5, and then from 4 to 6. So from -4 to -2.5, or 4 to 6. So justifications, these are my justifications right there. Okay? Absolute maximum and absolute minimum. Okay, so absolute maximum and absolute minimum, we got to do a couple things. The first thing we have to do is find any critical points or critical values. Okay? So I'm going to make a little table. X, capital F of X. Okay, so let's go back to the graph. Where are critical values? How do I know where are critical values on this graph?
The lowest points or the highest points?
No, that's something different, yeah.
Where it changes from positive to negative or negative to positive.
Where the first derivative changes signs, right? Where the first derivative changes signs. So if we want to know where the first derivative changes signs, where am I going to look? The x-axis, right? Yeah, where it changes there and there. Those are critical values. Because we said earlier the first derivative refers to the y values. Where do the y values change signs? Negative 2.5, positive 4. Okay, so I'm going to go down to my graph, or my table, sorry. I'm going to put negative 2.5 and positive 4. And then you also want to put the beginning and end of the interval. What is the beginning of the interval? Negative 4, right? And the end of the interval was positive 6. From negative 4 to 6. That's the first step. Now I have to figure out what is capital F for these four guys. What does that mean? What capital F is for these four guys? What do I mean by capital F?
The y value?
No.
We're finding the value like we did at the first.
Exactly, like we did for A, B, and C. For A, B, C, and D, you're doing exactly what we did for A, B, C, and D for those guys. You're finding area under the curve. And then whichever one is the highest area under the curve, that's the maximum. Whichever one's the lowest, that's the minimum. Okay, so some of these we've done already. Some of them we've done already. Okay, so let's see. Negative 4 we did, right? Negative 4 was negative 2. So negative 4, we don't have to do that one again. That was negative 2. And 6, yeah, we did 6 as well, right? Yeah. 2 pi minus 2. So we did 2 of them already. 2 pi minus 2. So we just have to do area for, so area, remember it starts from 0 and then it goes negative 2.5, right? So this is f of negative 2.5. Those bounds need to be flipped. So we get negative 1 times negative 2.5 to 0. Okay, so let's go find area from negative 2.5 to 0.
3.
Yeah, we kind of actually did that, right? It's this area here. And it was actually 3.5, wasn't it? Mm-hmm. It was 3.5 because the area here was 1, and then the area here was 2, and then the area here was half. So it was actually 3.5. Yeah, it was actually 3.5.
But it's negative because we have to switch it.
But it's negative because we flipped the bounds. So negative 1 times 3, and we get negative 3. That's for negative 2.5. Last one, f of 4.
2 pi.
So it's, let's see, 0 to 4, right? F of t. We don't have to flip the bounds on this one. So from 0 to 4, I think, was the half circle, right? From 0 to 4 is the half circle. So we did actually find that area, right? One was pi, and the other was pi, so it's 2 pi. Yeah.
I thought it was 3.5. Did I miss?
Oh, yeah, that's right. Yeah, 3.5. Yeah. No, you're right. Yep. Sorry, yep. Okay. So yeah, so now the easy part. Which one's the highest y value? Which one's the lowest y value?
Negative 2.5 is the lowest and 4 is the highest.
Lowest. That's going to be our min. Highest is that guy there. Negative 3.5 is smaller than negative 2. And 2 pi is bigger than 2 pi minus 2. 2 pi is around 7.2, 7.3, 7.3-ish. 2 pi minus 2 is 7.3 minus 2, which is 5.3. So yeah. Okay, so let's write this down. All right, so absolute max at, we don't write the x value, we just write the y value. For absolute max and mins, you're just writing the y value. So absolute max at 2 pi. That means that's the most area we're going to have from negative 4 to 6. That's the most area we're going to have. The least area we're going to have is negative 3.5. Okay.
How do we justify this?
So this one, yeah, you don't really, the work justifies it. The table really justifies it. There's not really a justification for absolute maximum or minimum. Yeah, sometimes they'll do that, sometimes they won't for absolutes because there really is none. Just it has the highest y value, has the lowest y value. Okay. Okay, concave up, concave down, and inflection points. Concave up, concave down, or inflection points. Okay, we know the justification is going to be second derivative is positive, second derivative is negative, or where the second derivative changes signs. Now, what is the second derivative?
Slopes.
That will be slopes, right? We got to go down 2 levels. Slopes. So we want to.
Second derivative of the little f. So wouldn't that be?
No, so see, yeah, this is back. I used this from last semester when we started with little f. So second derivative for us will actually be this guy here, yeah. Yeah, because last semester we didn't have area, so we didn't have this top level last semester, right? We started here. Yeah, so this semester, since we have integration, we start up here, yeah. Okay. So yeah, that's where it gets a little confusing, for sure. Okay, so slopes. So we need to find where slopes are positive, where slopes are negative.
From negative 4 to 3.
Yeah, so it's where it's going uphill, where you're going downhill.
Downhill.
So let's see, let me highlight this. Okay, so uphill, uphill, and that's it. Downhill, downhill, downhill. What about the guy I didn't highlight? Is it? Yeah, so it's just going to be, it's not going to change signs, right? It's not going to change signs there, right? So at negative 2, it doesn't change signs. So at negative 2, the slope doesn't change signs, it goes to 0, right? And then again at -1, the slope doesn't change. There's no change, right? There's no change of signs.
So there would be no concavity then?
So not concavity, there won't be a point of inflection. Yeah, so let's go over this real quick. So concave up, concave down. So concave up from -3 to -2, and from 0 to 2. -3 to -2 and 0 to 2. So concave up from -3 to -2 or 0 to 2. Because second derivative is positive. Now it's not second derivative of f. Yeah, so all of these on the board, I have the little f's. For today, these are all capitals. Yeah. Those are all capitals for today.
Are we only gonna, like, on there, it says, capital F prime of x on a f of x graph are the y values?
Yes.
Are we ever gonna do it based off of f prime of x or f double prime of x?
Yeah, that's a great question. This is kind of a sliding scale. Let me erase this because it's going to confuse you. It's kind of a sliding scale, right? So we're starting up here, right? So this is the first derivative, second derivative, third derivative. But let's say they give us a graph. Let's say they already give us the graph, right? So let's say we start here. Then this becomes, it's a sliding, this stuff moves down. Yeah, so that might happen sometimes. Most of the time, they'll start you with capital F. But this is kind of a sliding scale. It just depends on what they give you, what the given part is. Okay. Yeah. Okay. Okay, so concave up is good, concave down. All right, so we're going downhill from -4 to -3, -1 to 0. And then also from 2 to 6. Because f double prime is negative. Okay. So again, these are our justifications. There we go. Points of inflection, though. We didn't talk about points of inflection. Okay, so points of inflection are where capital F double prime changes signs. So let's go over here. Slopes change signs, where slopes change signs. So where does slope change signs from positive to negative or negative to positive?
-3.
-3 is one of them.
0.
0 is another.
And 2.
And 2. -3, 0, 2. Because that's where slope changes signs. At -2, it doesn't change signs. It didn't change color, right? It's not anything, right? 0 is just not anything. 0 is not considered a number. It's just nothing there, right? So we can't say -2 or -1. Okay, so -3, 0, and 2. -3, 0, and 2. So points of inflection. X equals -3, 0, and 2. -3, 0, and 2. Because f double prime changes signs. Because f double prime changes signs. Yeah.
What if they, like, when we take the exam, what if the question that we get wrong is because we didn't include 0 as, like, a point of inflection?
You talking about x equals 0?
Oh, no, when the slope itself is 0.
You won't, because if the definition of where it changes signs, because it's positive, right? It's positive before, and then it turns to 0. That's not changing signs, right? That's changing values, but it's not changing signs. And then it's 0 and then negative. You won't get it wrong because it doesn't change signs.
But what if it goes from negative 2, 0, because 0 isn't a negative number?
Negative 2,
You can't
0.
have negative 0.
Yeah, you can't have positive or negative 0, right? So that's why it doesn't change signs. Only when it changes signs besides 0. Is that where you look? That's a great question because sometimes that'll come up. You're always okay with where it changes signs. Where the double prime changes signs, where positive changes signs, right?
So if you were to put 0, it would be wrong.
X equals 0? No, x equals 0 was a change signs there.
No, I mean like if you were to include that.
Yeah, so where would you include it? If I say negative 2, it's wrong because it didn't change signs, right? It didn't change colors. Negative 1, it didn't change colors, right? So this is kind of like a gap. So yeah. Okay. It's kind of like with it's the same issue as our increasing, decreasing.
If it didn't change signs, then why didn't we go from negative 3 to negative 1? Because it didn't change from positive or negative, but it changed into a negative at negative 1.
So where did it change though?
At negative 1.
But it didn't change because it was 0 before that. So here it was 0, right? So it didn't change. Didn't change from 0 to negative, right? I see what you're saying. It's kind of a hard thing to get because it did change, but it didn't change, right? That's the thing, yeah. So we have to pick a specific point at which it changed. Did it change somewhere in this area? Absolutely. But when we're picking values, we have to pick a specific value, and there's not a specific point at which it changes signs completely yet. Yeah, I totally get what you're saying. It's kind of a confusing thing because it did change. Yeah, it changed in the area, but it didn't change at a point. Okay. All right, so the last thing, 7 and 8. Actually, no, it should be 8 and 9, right? 8 and 9. I want you to do those on your own. Those are practice problems. I want you to do those on your own. And then we'll talk about them, and then we'll be done for today. So these are kind of like the questions we just did. They just ask you one question, though. It's not like A, B, C, D, E, F. It's just one question.